One more proof type to talk about is what's called the existence. And with existence, there's two types. There's constructive and non-constructive. Constructive is um, something like prove that there exists an integer. So prove that there exists an integer. Um, in fact, let's make it a slightly more interesting. Prove that there exists a positive integer that is the sum of two cubes in two different ways. Okay, and so there's what are called taxi cab numbers, which are exactly these. So 1729, Google taxi cab numbers should get a possibly apocryphal story between Hardy and Ramanujan, so two great mathematicians of the 20th century. But anyways, from this story, you get that 1 cubed plus 12 cubed is 1729, but that's also 10 cubed, which is 1,000, plus 9 cubed, which is 729. So here's a constructive existence proof. Prove that there exists an integer that's the sum of two different cubes in two different ways. This is as strong of a statement as you can make. Here's the integer, done. It exists. Here it is. Okay, you're handing it over. Here it is. There's also what are called non-constructive. So non-constructive proofs. And these are things like prove that there's some property, so maybe we could prove that some property, that there's some object that exists that has a certain property, but you can't actually come up with a concrete example. So one example of this would be the intermediate value theorem. So prove that, say, x cubed plus x plus 1 equals 0 has a root. And the way that you can do this is by the intermediate value theorem. Okay, so the intermediate value theorem says that if you take this function f, which is x cubed plus x plus 1, and you plug in, say, -1, what you'll get is -1 plus -1 plus 1, which is -1. And if you plug in 0, you get 1, which is positive. And since the function's continuous, this means that at -1, -1, it's there, and at 0, at 0, 1, and so somewhere it's got to cross the x-axis at least once. This does not tell you where it crosses the x-axis, but it does prove that there's a root. Okay, so this is called a non-constructive proof. It still tells you something, but it's not quite as good as a constructive proof in the sense that a constructive proof says, here's your actual example, and then that's the end of the story. Okay, so these are both called existence proofs.